Good afternoon to everyone. Thank you for joining early. Looks like we got a minute or so before top of the hour. We're going to give it at least that, and then probably 1 minute after, just to give everyone a chance to log into their devices and get ready to go for training. So just hold tight, and we'll begin here shortly. For those that are just joining, thanks for joining. Appreciate it. Looks like we're at top of the hour. We're going to give it about 60 more seconds, allow for everyone getting off other meetings and getting logged into the software. Make sure we give them a chance to get logged in and ready to go. So 1 more minute and we'll begin. Alrighty, everyone. I think we are going to get this party started. We got a lot to cover today. We want to make sure that we can get through everything, and we always leave time at the end for a little bit of Q&A. So we want to make sure we have time for that as well. So thank you for coming, spending an hour with us today on the best practices on the fourth generation system. My name is John Webb. I am a trainer here at Enphase, based in the U.S. Alongside me, presenting is going to be Jarrett. So Jarrett, thanks for joining. Are you there, Jarrett?
I am. Thanks for
Yeah,
having me.
awesome. Yeah, great to have you. Also in the background, we have a few folks from our engineering teams. So first we have Sunil MS, which is part of our digital engineering. So Sunil, thanks for joining and answering back questions in the back end. Also Usaf Ghosh, senior director of our PLM team. Thank you for also joining as well. Also, we have a few other colleagues. Peter Lum, director of training. Thank you, Peter, for joining and helping out with the polls and providing insight. And then I think we also have Danny Heidowitz as well. He's another trainer based in California. So thank you for everyone for the support as we go through today's webinar. If you guys do have questions, we definitely encourage them. So within your GoToWebinar app, so on your phone, your tablet, or your laptop, there's going to be a little questions tab. Go ahead and select on that. It's going to open up that, and it's going to allow you to actually go ahead and enter your question in there. And the folks that I was just mentioning will be on the back end, be able to see those, and then also be able to respond to those as well. So definitely, if you have a question, or something wasn't totally clear, go ahead and type that question and we'll get it answered for you. Today's agenda, we're going to go through resources first. So we want to make sure everyone understands what's out there at their fingertips, or they can save it to their phone, save it to their desktop or their computer, and get resources of our Enphase products. Then we're going to dive into the key components of the fourth generation, which is going to be the 10C battery, the combiner 6C, and then the meter collar. And then we're going to end off with the commissioning best practices. And then, like promised, we'd like to go ahead and close out with a little bit of Q&A and allow everyone to ask questions and kind of go through that as well. So resources, what do we have? So first up is the best practices tech brief. So hot off the press this morning, If you go to the materials tab within the GoToWebinar, that's a brand new document. It's freshly updated, has all the newest, latest, and greatest. So you can go ahead and grab that, download that. Highly recommend saving it to your device. So everything we're going to cover today is in that document. You can also take your phone and use the QR code here on the screen and get access to that as well. YouTube channel, don't want to forget that, call that out. We do have a YouTube channel here at the Enphase training team. We post videos pretty frequently, anywhere from a minute up to 4 or 5 minutes, all product related, best practices, tips, tricks, how-tos. We kind of throw a bunch of stuff on there, and we actually have a dedicated section on our channel for fourth generation. So if you're looking for fourth generation specific topics, we have that. You can use the QR code here. Definitely subscribe, so whenever we do upload new stuff, you're going to get notified, and you can go ahead and pop that up and see what the newest, latest, and greatest is. And then what we're doing today is the best practices webinar. So if you don't know, or if maybe you've been along for the ride all along, we've been doing this since August, and originally was only going to be about a 6-week series, but due to the popularity, the feedback from folks like yourself, we're going to actually continue this all the way to the end of the year. So same time every week, every Thursday. The only week that we're not going to be doing these is going to be the week of Thanksgiving and the week of Christmas. So we won't see everyone here those 2 weeks, but all the other weeks we're going to be right here at the same time, and hope to see everyone here. I also want to just say this webinar changes weekly. So if you've joined us, yes, there's a lot of stuff that maybe you've heard us talk about, or we've said, but we do add new stuff as we learn from the field, as we go through more installations. So this week we have a new topic, so hang out, you're going to see what that is. But yes, it does change. So it's not a one and done webinar, like once you see it, you're done. Again, there's new stuff that populates every single week. So, okay, let's go ahead and get into the pre-installation best practices. Jarrett, I'm gonna let you take this one here. What do we got to make sure everyone understands?
Yeah, thanks, Sean. The first thing we should always know that, when we install the fourth generation system, right, we have to be certified in order to be able to commission our systems. So the Enphase University has been updated with the certification process and the program for the fourth generation system. Everybody who is going to be doing commissioning, they have to go through that. Anybody who's doing the installation, it's highly recommended they go through it as well, just to make sure that they understand the ins and outs of the product and really have a great foundation for when they get out there in the field. So again, the Enphase University has the fourth generation certificate specifically for the new products. You have to be certified in order to commission. So that's the thing we want to stress about that. And we're always adding things to it. Like John says, our YouTube channel with the university, we're also doing that as well. We're updating, we're adding new things, new courses, new lessons. So make sure you and your team are all on board with that. And if you need to know who is trained at your company, there is a video that we have out on YouTube channel on how to access through Enlighten Manager to see who is where at in the process of getting certified. And so maybe at the end, I'll try to get a link for that we can post, and you guys can go and run a little audit to figure out who's been trained in your company.
Good. Yeah, I love it. I also want to say that we have a design certification as well. And the reason I bring that up, if there's any designers on the call, awesome. Thanks for being here. Or if you have designers in your company, let them know, like, we have a specific design, certification for them. And the reason I bring this up is some of these best practices, this is the feedback we've heard. It's like the installer's like, well, I'm just building off of a single line. Cool. Well, if the single line's not correct because maybe a designer doesn't know it needs a specific type of wire or cabling or a certain process, like then they're setting up the job for failure at the beginning. So foundation from the design, obviously carries on to the installation. So if both of those teams are on the same page, they're going to make these installations much more smoothly. They're going to go more efficiently, and there's not going to be return visits for missed items and stuff like that. So designers, either you're on the call or if you have them in your company, make sure they understand we got a cert for that. Get them in there to take it. All
Yep.
right.
Thanks, John.
Yep. Cool. jump into the battery 10C best practices. What do we have here, Jarrett?
Yeah, so for the 10C, the thing that we have to remember is, the 10C is actually two battery subunits that get tied together. And so with the new batteries, we have microinverters just like we had in the past, but there's only two microinverters per subunit now. And from the factory, the power pack, the battery pack is actually not plugged into the microinverters for power yet. So we have to remember that when we install these guys, we have to plug in the DC connector from the battery pack into the microinverter so they get power. What we've seen out there in the field is we've seen people, wire everything together, put the cover on, and they forget to actually attach the battery pack to the inverter. So we're going to have some issues down the road when we try to do commissioning. So again, we want to make sure that we plug in the DC to the inverters before we put the cover on themselves.
Yeah, no, that's definitely important. Yeah, good tip there. One thing I do want to add is there's specific little indicators on these plugs when you actually press them in as well. So you can see this picture here on the right. When you push them up, there's a red and a white little indicator line. You'll hear an audible, and then when you fully click them in as well, you should see solid white. If you see any red, that means those aren't seated correctly. You need to pull them out, reposition them, and then make sure they're seated good as well. And
Yeah,
then,
that's a great tip. Yeah.
yep. And at the bottom there, Jarrett, too, this was kind of one that we want to make sure guys really, we have in red down there, we really, understand if there's, no PTO. So meaning, so two things here. If you don't plan on commissioning the system, like you're just going to install it and then somebody else is coming out, or maybe you just don't have enough time and you're not going to know when you're coming back out. Don't plug these in. Okay, so we don't want to actually, plugging these in will draw a small current. We don't want to drain that battery if we don't have PTO or you don't plan on commissioning these for, I don't know, 3 weeks, month, things like that. We want to make sure to keep these unplugged so we don't drain that battery down to a irrecoverable state. So again, keep these unplugged if you don't plan on commissioning right away, or if you do plan on commissioning but there's no PTO on the system for say like a month. Go ahead and plug them in, commission, and then once you're done commissioning, go ahead and unplug them again, so we don't drain that battery, down to a state that we can't recover it. So cool. What do we have here, Jarrett? The battery wiring between those subunits you were talking about.
Yeah, so when we talk about the batteries and when they're mounted to the wall, there is a wall side battery and a user side battery. So those two separate subunits. And when we do the wiring for these guys, we need to wire these two batteries together. And so what's different about these is from our previous generation products is because we have the inverters that actually form the neutral in here, we actually need to wire these guys a special way. So in the box with these batteries, you guys will get a bag that has wires already pre-colored, if you will, and you'll see here on the example, we have a wire that is partly red and partly black. And so we need to wire these in the correct way. So we need to connect the L1 portion of the wall side battery to the L2 terminals of the user side battery. And then vice versa for the L2. The red is going to go to the black. So the L2 is going to go to the L1. So that's really important. We need to make sure that we have those phasing set correctly for that. If we do make a mistake during the commissioning process, the tool will catch it through the installer toolkit or the installer app. It will recognize that, but the problem here is it's going to take you additional time to remove the battery cover to get to the wiring at the top again, and then redo the wiring and then power back up the system. So trying to make you guys really efficient in how you guys are wiring the system in correctly the first time, just to save you essentially time and money, not having to remove different components again to correct those issues and then put it all back together again. Now, if you lose that bag full of wires, you can still run your own, but what we've seen is people don't use phase tape and they don't color code them correctly, and that's where some wiring issues start to take place. So again, we want to make sure that you guys keep the bag that we give you, use the wires that are sized appropriately to go in between the chase and between the two batteries, and make sure we do that. We will have to wire in, line 1, line 2, the neutral and the ground. So that's the other important thing as well. And So with the previous gen products, we didn't have the neutral, right? So with the 10Cs, we do. And so we want to make sure that everybody's aware of that and not to make that mistake of not wiring in a neutral with these batteries.
Yep. And that's a great point, Jared. I'm glad you brought that up. So the neutral capability with this battery, and then that extra conductor. So yeah, make sure we're not forgetting that. And where I mentioned it earlier about there's a design certification. So what we've seen on a handful of cases is design creates a single line without the neutral. Installer goes out,
Mm-hmm.
even though he's certified and he probably should know that there's an actual neutral. He builds it just strictly off of the single line and doesn't add the neutral, which obviously is going to cause issues. So again, that was the whole point of mentioning of the design cert earlier, that if it's caught from the design, it's recognized that it should carry all the way through installation. So yeah, good call out there, Jared, on that neutral. When we're wiring, say, multiple 10Cs, Jarrett, it's a little bit different than the subunits, isn't it? So what do we have here?
Yeah, so essentially in this one here, we have two 10C batteries, and you'll see that coming from your combiner box, so coming in from the left, you'll see that we have line 1, line 2, a neutral, and a ground coming into that wall side battery. Now then the wall side battery is going to get wired into the user side subunit, right? So again, we're going to swap our phases there. Now when we connect the two batteries together, we're going to use only the wall side to wire those two batteries together. So you can see it comes out through the center of that chase into that other battery. And then once we get there, then we're going to wire it like we did the first one. We're going to wire the wall side battery of that second unit to the user side subunit as well. And again, we're going to carry over the line 1, line 2, neutral and ground into that as well, along with the comms wire, which we're going to get into in upcoming slides. But we're not going to go, user side to user side when we do wiring. That's all going to be done through the wall side, through that chase in between. And again, make sure we're always bringing in a line 1, line 2, neutral, and a ground from our combiner box. So that's a big takeaway there. We're, again, 4 conductors coming through, using only the wall side battery units to wire those two batteries together.
Yeah, good stuff there, Jared. I like how you said neutral multiple times. We just want to make sure everyone understands neutral, neutral, neutral. We have one in this battery. We cannot forget it. So yeah, awesome, Jared. Love it. Um, let's talk a little bit about the DC switch connectors on the left-hand side of the
Mm-hmm.
battery there, Jarrett. So what's important there?
Yeah, so the DC switches, and these are the DC disconnect switches, right? So from the factory, they're going to come tucked in to each of the battery subunits. There's going to be 2 of them because we have to have 2 DC disconnects, 1 for each battery subunit. Now, when we put the cover on, we want to make sure that those wires just aren't dangling. We want to make sure that those wires are stowed anytime we put on the cover or remove the cover. And where we stow those, if we look at the graphic on the left, 2A and 2B, there is a little metal connector section. I don't even know how we say that, but there's a spot to stow each of those wires, and they just slide on there. And what we've seen out there in the field is people not do this. And so those wires are hanging, and either when they put the cover on or take the cover off, that will actually damage the connector and or the wire. And that's what we don't want you guys to do. That will trigger calls to customer service, possible RMAs, right? So again, we just want to bring to your attention of things that we've seen out there in the field where, again, it's trying to make you more efficient and not have issues while you guys are out there. So anytime you put the cover on or off, or take it on or put it on and take it off, those wires, DC connectors, have to be stowed in their respective spots before we pull that cover off or push it on.
Yeah, we've seen a fair amount of this, Jarrett, where guys just leave them dangling. They pulling off the metal cover, and well,
Mm-hmm.
not coming easy. What do? They pull a little harder, and when they pull a little harder,
Yep.
they end up breaking something. So if it's not coming off easily like it should, stop. Make sure that you look at, hey, the connector's off. Do I have everything, in the right format to get it taken off? We're going to cover that coming up, but
Yep.
to Jarrett's point, do not pull these off, the cover off without holstering first. So, yep, very important.
Correct.
Cool. There is, Jarrett, a right and wrong way to actually install those.
Sure
We have to
is.
a certain way. So what do we got to know here?
Yeah, so when you go to put those connectors actually into the DC disconnect switch itself, there's two ways it can go on, but there's only one correct way that it should be. So on the left-hand side, you'll see that's the correct example, and there is a little latch that John's pointing to right there. And as we slide that connector into the slot, it'll actually click in there and lock in there. And give a good little tug test on it to make sure that it is secure. The one on the right-hand side, that connector is actually flipped around, so that latch is on the back. And so when you slide that connector in, it actually won't latch or catch. And so when you do your tug test, it's just going to pull out. So that's the incorrect way. We want to make sure that that latch is always facing outside. And when we secure that connector into the header, I guess, right, when we slide it up, we're going to make sure that that clicks in and it's secure. So those are the big takeaways there. We've seen people not do that. They've done it the incorrect way. And over time, it will come out, which we don't want.
Yeah, definitely do not want that. Turning on and off the batteries, folks, is a little different from our third generation. Again, we highlight this very well in our certification processes and training, but we still see folks just not think about it, struggle with this, and then it ultimately causes delayed commissioning times and within the system. So Jared here, there is a difference, isn't there, Jared, on this one when they power on and power off, isn't there?
Correct. So when we power on the batteries, the thing that we have to know, John has a little video we're going to play here. When you go to power on the batteries, you're going to go ahead and press and hold that battery button for 5 full seconds. So that's a 5 schoolyard Mississippis. And when we do that, then we're going to see the light start to flash, but you have to hold it in for a 5 full seconds. That's the thing that a lot of people miss. Again, they're used to using our previous generation batteries where they just have to press the disconnect button once and it starts to light up. This one you have to press and hold for 5 seconds, and then the battery will start to do its boot up sequence with all the various flashing lights of reds and greens and such. So that's the first thing that we have to think about. Press and hold 5 full Mississippis.
Yep. Yeah, very good. And just to call out, folks, when you're powering on, even powering off, you can use wall side first, then user side, or vice versa. You can actually do them at the same time. So it doesn't matter what battery cell that you start with or end with. So powering off is very similar, isn't it, Jarrett?
Yep, powering off is a little bit similar. The thing that's different here, though, is when we press and hold that button for 5 full seconds, what's going to happen is those lights are going to stay on for up to 30 seconds. We've even seen them as go as 35 seconds. So again, press and hold. They may not do anything right away because the lights are still going to be illuminated, and we just have to wait it out for that 30 seconds to make sure that those batteries will fully turn off at that point.
Yep.
So want to make sure that we follow that sequence as well. Again, this is where people get tripped up. They think they can just press and hold the button, and we just want to bring it to your attention that that's not the case. You got to press and hold, and then you got to wait it out.
Yeah, one thing you don't want to do, like Jarrett mentioned, 30-ish seconds. When it's flashing that red, a lot of people think there's something wrong. That's actually part of the boot out sequence. So what we do not want is during the flashing red for up to 30 seconds is we do not want folks to actually, press it again like something's wrong. It's doing its thing. By pressing it, it'll actually disrupt that power down sequence and actually might not power it all the way down, which we obviously don't want that.
Yep, correct.
So, yep.
Yeah, it's part of that process, as you said.
Yep. Cool. Let's talk a little bit about removing the 10C cover. So Jarrett was making some good points earlier that we must holster some of those wires before we pull off. So let's kind of walk through that 5-step process. So first is going to be turning off the actual battery cells. Again, you can do them together. You can do one at a time. What we just covered, it's a full 5-second press, and then make sure that you let them totally stop flashing before you actually start, pulling the cover off and disconnecting the switches. So again, wait that 30 to 45 seconds. Once you power down the battery cells, we have right and left screws on the cover. They're kind of up on the front side of the cover on the upper left, upper right. So go ahead and get those taken off. And then we do need access to the bottom left and bottom right of the actual battery. So this is why it's also really important to give yourself ample room, especially if you're, installing the, multiple batteries. A good 8 to 10 inches is really what we want between the batteries, so you can get access to the switches, you can get access to the doors. We don't want them so tight that you can't open those doors and have a workable space. So get access to the doors. And then, like Jarrett was mentioning earlier, we want you to disconnect those DC switches and holster them like you have here in 2A, 2B. What we don't want is just, undoing them, letting them dangle. And then the next step here is actually pulling the cover off. And if you don't holster them, they very well could catch and break. So we don't want that. The final process of the removal is on the front left and front right. There's these little pull tabs, little release levers. So you simply just engage those towards you, and then give the cover a good little pop, towards your body, and that will release that cover and allow you to easily and safely, without damaging anything, pull that off and then get you access to that battery.
Yeah, just to go along with that, John, the last couple of days I've been seeing some calls come in from customer service saying that those levers have been broken. People have been forcing that cover off. They don't realize that they have to push those in to release the locking mechanism for the cover. And so, like you said, they just try harder. And so they'll kind of yank and pull on it, and that actually will break those locking mechanisms. So
Oh,
again, just want to make sure that you guys are fully aware that you have to push those in to release the lock so that cover will come off. Don't force it. From what I'm hearing, those parts are a little bit difficult to get as replacements for the cover. And so just again, want to reiterate, those levers are going to be key to making sure that cover comes off nice and easy.
love it. Yeah, that's great feedback, Jarrett. Firsthand, that's from customer service, taking calls all day long. So right there, that's what we're seeing, folks. So let's not do that. Let's go ahead and give them a little learning check, Jarrett. Make sure everyone's paying attention and kind of test their knowledge. So what we're going to do here is, here's the question. So this is all around the 10C battery, what we were just covering. So the first question here is, identify if this is wired correctly. So based on this photo, take a second and look at the wiring to make sure that it's actually wired correctly, or if you think it's wired correctly. There's one of these answers is going to be correct. So A, B, or C. So it's either all good, it's wired correctly. No, there's a phasing error, or no, there's actually a neutral wiring error. So Peter's in the background. We're going to give it about, I don't know, 5 to 8 more seconds. Then we're going to launch a poll, and we want everyone to answer correctly what the correct answer is. So we'll give it 5 seconds, and Peter, go ahead and launch that poll for us, please.
You got it in 5, 4, 3, 2, 1. Here we go.
Five more seconds for everyone to answer. All right, Pete, let's go ahead and close that poll, and let's see what our results are.
Yeah, John. So it looks like about 80% of our attendees feel that there is a phase error in the picture that they've identified, with a few people indicating that they think there's a neutral error, or a few people also thinking that there's that it's wired correctly. So what's the answer?
Yeah. So I'm going to go with 80% and say that there is a phasing error. So I think that's correct. And folks, I'll take responsibility. I probably should get maybe a little better picture for a few of you that maybe didn't quite see it. But if you simply look down here at the bottom battery, and you kind of look at the blocks, and then knowing your colors, kind of what the colors should be. Okay, looking at this, yeah, that looks good. And then as you it's kind of hard to trace it through the raceway. I totally understand that, folks. But what I'm looking at here is, if you look at the blocks up here and kind of see where the wires go in, and you kind of see the blocks first, you have the ground, line 1, line 2, and neutral. You should clearly see that there's a phasing error between line 1 and 2 up here at top, that they actually didn't follow the phase switch, and they actually went phase to phase. I was actually witnessed this. I knew the installer that did this. Total honest mistake. I talked to him about it, and he totally owned it. We obviously, it took us about an hour because we found it during the commissioning part. But we were able to fix it, remedy it, and be able to close out the site and commission it. But to his point, he's so used to landing line 2 to 2, 1 to 1, and he didn't actually just pay attention, even knowing that there's a phase swap even on the wires and stuff that he needed to do it. He just kind of blanked that out from years and years of being an electrician and just wiring that way. This is very specific how we must phase swap our subunits within our 10C. So cool. Awesome. Well, I'm glad to see most got that right. Alrighty, let's go ahead and dive into the Combiner 6C best practices. So this one is a new one, folks. So this one's not quite out yet, but little sneak peek. So this new feature, this new item is going to be coming with the ITK version, installer toolkit version 4.8.5. So currently we're on 4.8.4. Okay. So very soon, and from our engineering team, we've been told kind of late next week into the following week, kind of the week of Thanksgiving, is when we should expect this. So what did we discover? So the IQ Gateway reset button, we're going to call it the removal process. So early manufactured Combiner 6Cs, okay, with specific serial numbers. So they start with 4825. Okay, that's the first four. They're going to be all that. And then really where we want to focus is on the 5th and 6th digit within that. So you can kind of see below here in the bullet points, I have them highlighted. So the 5th and 6th digit is actually what's going to determine if we're going to remove that button or if we're actually going to keep it in there. Okay, so great thing about this is you're not going to have to necessarily focus too much on that, but we want you to understand where the logic's coming from is actually from the serial number, the specific, the 5th and 6th. And what we've identified is on the 5th and 6th digit, that's 38 and less, that button has a tendency to potentially stick. And when it sticks, it actually puts that gateway in a constant loop where it turns itself off, turns itself on, turns itself off, and it kind of goes back and forth. And folks, as you know, that's obviously not what we want for the system functionality. So what we're doing in the new 4.8.5 update in ITK is when you scan in your Combiner serial number, we're going to have like a spot check. The software is actually going to recognize the serial number for you, and then there's going to be this little pop-up here. And what it's going to do is like, hey, we recognize the serial number to have potential button sticking, and what we want you to do is actually just simply remove that reset button. It's very simple. You can literally just take your fingers like the picture here, reach in, pull it out, or gently use like a pair of needle nose. Very simple to pull out. And there's also going to be a 4-second video that you can play to see this process. Very, very simple. But yeah, just letting everyone know, coming up in 4.8.5 ITK version, again, probably a couple weeks out. This is going to be new. You will see this. Again, the fix is to get rid of that or pull that button out so it doesn't put that gateway in a constant loop. So Jared, that was a mouthful. That was a new one this week. Hopefully that made sense.
Yeah, no, it's something that's popped up and we identified. So again, just learnings from the field. We're bringing this to you weekly of things that we're learning about and want to draw your attention to it. So we understand what's happening when we're out there.
Totally. Absolutely. So this one is new as of last week. So if you heard last week, this was a little review, but we just put this one in last week as well. So this is going to be the PVA. So it's the PV aggregate breaker. So that's going to be that pre-installed 60 amp breaker in the bottom right of the upper bus bars there. So you can see here I have the little red square around that. So that's factory shipped with an Eaton BR60. Okay. I just want to make sure it's very clear that Siemens and Eaton are allowed within the actual combiner except for this breaker slot. So this has to be an Eaton BR breaker only. So if you do 3 branches of PV and less, no need to change it. If you actually do 4 branches, or maybe that 5th branch circuit, you will need to pop that out and put an Eaton BR80 or an Eaton BR100 in there. Again, Eaton BR, no Siemens, okay? Again, only need to swap that when you go to that 4th and 5th branch circuit. Let's talk a little bit about torque requirements. So, gosh, I was just talking to a few folks and our FAE team during White Gloves and stuff, and we are seeing this this week, last week. We're seeing it every week, unfortunately, folks. So what's happening is installers are putting the wires in, and they're not torquing anything. So anything within the combiner, that's the back feed lugs, the neutral bar, the ground bars. I mean, shoot, even the breakers themselves, they're very loose, and those wires are creating thermal events. And I think we all know what happens when thermal events happen within the combiner. Obviously, heat builds up, potential for arc, and worst case, which we don't want is fire, anything like that. So within the combiner, you can see it highlighted in the red here on the right. We have torque specs, okay, within the neutral bar, the ground bar, the back feed lugs. Obviously, it actually specifically shows like, hey, what wire size you're using, and those torque values might change slightly just because of the different wire sizing. So we want to make sure everyone's properly torquing these correctly. I know, Jarrett, you're saying you live in an area that when an inspector comes out, they make you torque several of them to prove that they're right. Is that right?
Yeah, absolutely. They're, it's been starting in the Central Valley as of, a couple of years ago. And at inspection, the inspectors will actually have an installer out there with them, and he requires them to show a torque setting. So they go through and torque it, and then use a paint pen to show that those are torqued. So just make sure you have a torque driver in your bag. I just put a link in the chat for everybody. Some people will always ask, what torque drivers are out there. This is one that I've purchased for our training centers in the past. They work very well. And the prices range. I mean, you can get different ones that are as cheap as, $89 from, Husky brand from Home Depot. I think that's Home Depot. And I've seen them go as high as $350 if you want to get the fancy one. This one here is like $1.25. And it's a good one. It does what we need to do. But like John said, I mean, inspectors are starting to require people to torque in front of them during the inspection phase. So I just want to make sure you guys are prepared, make sure you guys have those torque settings handy, make sure that they are all torqued. We've seen where with these wires and conductors have not been torqued, you can wiggle them, bad, unsecured wires will, start to arc and things like that. We don't want that. So torque.
Yeah, love it.
Yep. Yep. Can I say something about that too, guys? I mean, I've seen a couple sites where the main feeder lugs were not torqued down, and actually, a field service tech went out on site and physically had 2 to 3 turns on the main screws for the back feed lugs. And quite frankly, how it shows up is the system, obviously, like Jarrett mentioned, thermal events, but we've even seen the system not operating in off-grid mode, certain things happening, just weird stuff. And we send out a field service tech. They do a thermal imaging camera before they start. They see where the issues are coming from. And we've seen, just quite frankly, and I get it, it's end of the year. Everybody's pushing as fast as possible to finish installs, but we're seeing like, 2 to 3 turns on a screw, either on the combiner's main lugs or even on breakers themselves. So I know all of us, say, oh, I've been doing electrical for years. Well, I got to tell you, we've been seeing them. So what, the customer service teams told us, if they find an FST goes out to site and finds these sites, they're going to mark the serial number and then just quite frankly, pull it out of warranty status because it wasn't installed to manufacturer specs. So just FYI, keep it in mind. It's important.
Yeah. Awesome, Jeremy. Thanks for that feedback. That's good to know. Really appreciate that. Cool. We got one more on the 6C here. Again, these 3 were new from last week. So this is going to be the load control CT requirements. So this is going to be for grid tied mostly combiner 6 installations. So customer gets the combiner 6, they put PV up, and there's no meter collar. And what's needed then, if there's no meter collar, is we actually need to install consumption CTs. If you're using a meter collar, the consumption CTs are actually built into that, so there's no need for CTs or extra CTs. So again, for grid tied scenarios, what we need to do is we need to use the port of the actual where the load controller the factory blue and white wires are actually CTs for the load controller. So what we need to do is actually disconnect those. That's where the wiring of the new consumption CTs are going to go. But what's happening is installers are actually just removing that factory whip, and we're just letting it dangle in there. Okay. And what the harm is that actually can carry current through it and potentially cause an arc, and potentially hurt someone. So what we actually want to do is up here in this picture where my cursor is, we actually want to remove that header. Okay, so be careful when you're moving it. Remove that header of that CT, of that load controller CT, and then what we want to do is actually cap those individually, just so when we have them dangling in there, if there happens to be current run on that load controller or get to the load controller, that it obviously doesn't arc, potentially hurt someone, shock someone, things like that. So again, when you are wiring consumption CTs in, we want to make sure that we pull that header off of the load control header and actually just wire nut those for safety. Alrighty, going to the next one here. Jarrett, I wanted to throw this one in. We've been kind of, skipping over this one the last, I don't know, 3-4 weeks, just because, we've hit it hard. And I think a lot of folks know, why we, what we approve here at Enphase for, communication wire and stuff. But I've been seeing this a lot, Jarrett, recently. I don't know about you, but we've been seeing a lot of guys just kind of use whatever wire for communication.
Mm-hmm.
And quite frankly, it's not working well. And I was on a site just last week where they didn't have it. And guess what? When we got to commissioning, we couldn't get actually any communication within the batteries. So what do we have to do? We had to undo everything, first power everything down, and wire it up with this control cabling. And well, as soon as we did that, fired everything up, and it actually worked. So I just want to make sure everyone understands this is the only approved cabling, control cabling for like our communications allowed within our system. So Jared, do you want to talk a little bit why this is so important with like the colors and the shielding and everything else?
Yeah, the engineers who selected this wire, I mean, they selected it for certain properties that we need for our system. And out there, other people have found stuff that's maybe cheaper or similar, or like John said, they have it out there in their warehouse already. Maybe they ran out of our cable, and they said, well, we're just going to substitute this one in. And it may have the same rating, but what we found that it doesn't have the same electrical characteristics of what our cable has been spec'd out for. And so we will have issues down the road in terms of communications. So again, we want to make sure that we reiterate, the only approved cable is the control cable that we have selling through Enphase. It's got certain specifications that we're looking for. The color coding is correct. If you ever do run into comms issues and you call customer service, they're going to be looking and referencing the color coding that we have in our cable. And if they don't match with what you guys have, again, we're going to have some difficulties there trying to do some troubleshooting for you on site. So the cable, very important. This is the one that we recommend. It's the one that we require to have for our system. Don't substitute.
Yeah, and just if I may, one more time on this one, it's not Enphase ploy to sell cable. I can tell you that. So if you found same color and same spec, fine. It's just very hard to see the specs the same. So I know we've done side by sides on sites myself, where customer and I placed a bet. We threw down $100 bill and said, will this thing commission, with the standard gray competitor cable or whatever. And what happened was, and like John, I think mentioned this a minute ago, system got funky during commissioning. And just to be honest with everybody on the line, it's this cable that we spec'd actually does work with our products, whether it's out direct in the sunlight, whether it's in tray cable, whether it's in conduit, it's going to work. And just remember, Enphase products talk over power line, so like we're doing a lot of work there, and we're communicating and sending signals back and forth. And quite frankly, when you've got a control cable that is just your standard, I don't know, gray or blue stuff or whatever, not shielded, not approved, that stuff just ends up causing havoc with comms. It just does. And I can tell you, it's not because we source the finest copper in the land. I mean, shout out to Andrew Levine who came up with that terminology. But the reality is this stuff actually works and the other stuff doesn't. And yes, you might squeak one or two, sites that you were like, I installed that other cable and I think it's working. Well, I can tell you it's not going to work over time. I can promise it. So just FYI, really appreciate everybody. It's not our ploy to sell cable. It's just, this is the only stuff that works with our product.
Thanks, Jeremy. I appreciate that little explanation on that. I think we're all dying to know who won the $100.
Well, let's just say I'm wearing a very nice t-shirt today. That was $100 t-shirt. So
yeah, folks, use the Enphase. I promise you it's going to be better in the long run, and obviously for multiple reasons. So yeah, good stuff. Cool. Let's go ahead and dive into the IQ meter collar. Jarrett, I know there's some important stuff here we want to make sure folks are aware of, and let's kind of start with the header kind of positioning and stuff like that. What do we have here?
Yeah, so on the underside of the meter collar, there is our communications header, right? So that's going to be for our comms cable that we just talked about. Now, when we install these meter collars, they're always kind of in a weird, funky spot where when you're trying to get these connectors in, it's kind of a weird angle to look at it, to push it up in there. So what we've seen out in the field, again, these are all learnings that we've seen out in their field, and these are mistakes and things that we've seen over and over again. That's why we keep bringing them up. Is when they go to put that connector into the header, it's off by 1 pin. So there's a little bit of wiggle room in that little space that you see here on the screen. And it's a 4-port header, 4-port connector. And you can just offset it by just a little bit by accident. And you can push it in there. And what'll happen is you've only got 3 connectors that are actually making contact. Sometimes maybe not at all, but you can still push that connector in. And again, when you go to do the commissioning, that's when it's going to rear its ugly head where it says, hey, we don't have communications. Maybe that meter collar's not on, right? That red wire is what gives us our voltage to turn on that meter collar. So again, we want to make sure that when we go to put this header in, this connector into the header, that it's aligned properly. And when you push it in, you listen for that actual click. Remember, these are all locking. So as soon as you push them in, you're going to get that click. Do a small tug test. Don't go crazy and do the ugga-duggas and try to pull it out. But you want to make sure that it is secure and it's in there and it's not offset. And as John's showing here on the screen, same thing within the Combiner 6. We've seen those issues as well with the headers, not only on the meter collar one, which we're showing here in red, but also on the green ones for the batteries. We can have that alignment off just a little bit. And on the graphic on the left, or the picture on the left, you can see that there is a gap where that header was pushed in, or that connector was pushed into the header and it was off. You didn't make good contact. The one on the right is fully secure. You can see the locks tucked in there. And again, if you do a tug test, it won't pull out. So again, just things we've seen from the field that have had gotchas in the past that we've had issues with, and we don't want to have to power down the system, figure out where things are, then power back up again. Every time we do that, it costs real money in terms of labor and time and things like that. So less mistakes, the better.
Yeah, good stuff. Good stuff. Double check your work.
100%.
Talk a little bit about the junction box on the meter collar. So make sure that you actually have those captive screws actually fully seated. As you can see here from an installation, they don't. They're leaving a clear gap from the junction box to the meter collar. Dust, dirt, water, snow, debris, insects, whatever. I mean, stuff can get in there actually. And what it does, it compromises the NEMA rating. So just be fully mindful of that. Same thing kind of goes for when you're sealing the meter collar. We're using like a seal ring, like a screw type seal ring. We want to make sure that we're grabbing both the lip of the meter collar as well as the actual meter pan itself. So there's 2 lips that actually you got to grab, and then when you tighten that screw type ring down, it actually secures it really nice. You can see here, if you kind of position yourself on the right, you kind of taken from the left picture, gradually move yourself to the right side of it. You can see here they completely missed the lip of that actual meter pan. Again, not securing it correctly. If somebody came up and say a kid grabbed onto it, well, that's probably going to pull straight down. So next thing here is talk a little bit about the orientation of the actual meter collar. So there's actually specific right and wrong way to actually install it. So we want to make sure that when it's installed, that we have the up arrow, so you can see the little red box around the meter collar there. It's kind of hard to see, but when you have it in your hand, it's clear. But that's actually going to be up for a reason. So that's actually going to identify when it's installed into a separate meter pan, or when you install it into like the pan where the utility meter is going to be on top of it. This is going to ensure that we have the grid side jaws at the top and the load side jaws at the bottom. So as we've learned, we were talking about CTs earlier, this actually has the consumption CTs built in, and we want to make sure that we have phasing correctly, as well as polarity throughout the entire system. So again, this ensures that we have grid side at top, load side at bottom, and then that's also going to carry into a external meter pan. So this is going to be a common installation for areas where we don't have meter collar approval, or we're still going through the testing and waiting for that approval, where we'll have to put an external pan. And the learning here is we know that the grid side of the actual meter collar is at the top and the load side at the bottom. But what we've seen when electricians are installing this, they actually bring the grid side in the bottom, which is making the current flow from bottom to top, which is then going through those current transformers within the meter collar, the opposite direction, which is obviously causing errors, showing negative numbers, and we absolutely do not want that. So again, let me go back one here. Meter collar, again, up here, grid side, load side, wiring in an external meter pan. Again, make sure you bring your utility, your grid side at the top, load side at the bottom. Following those two is going to ensure polarity and phasing is going to be correct throughout the system. And then this one was new a couple weeks ago, maybe 2 or 3 weeks ago, but we've still seen a few of these popping up here and there. We want to make sure when you guys are shorting that meter collar, so this is when you're not putting the utility meter, on the meter collar. So this is when you're doing one of those external pans. So like this scenario here, what we need to do is we need to actually short the grid side and load side jaws. And it's going to come with a transparent cover with the utility or the meter collar. So obviously that's just for temporary use. That's not going to short those jaws. So what we need to do is use one of the Enphase approved jumper covers. So you can pick these up on our website. Also, the distributors out there will also be carrying these, so reach out to your local distributor, and they should have one or both of these for you guys to pick up. So first is going to be the Tesco, and the second is going to be the AEP. So we've actually tested these. They're UL listed, they're permanent rated, they're UV rated. They're made for permanent use, and that's why we're going to recommend these. And what we've seen is these jumper bars over here on the right with the red X, and that's just going to be a kind of a temporary solution. When you're testing, doing MPUs, you're doing swaps on some utility equipment, you could use those to simply, short those and do some tests, but they're not meant for permanent use like what those jumper covers are. Also with these bars, you don't have a way to really seal up that collar, which is obviously going to compromise the NEMA 3R rating. So again, learning here is use one of the approved jumper covers and do not use these jumper bars. All righty, let's get into some commissioning best practices. Jarrett, what do we have here with the load control configuration? I know we're on 484, so this is our current version right now, and we did have a slight change, didn't we?
We sure did. So with the load control, what we've seen out there in the field is people have commissioned a system Well, I'm sorry, let me back up a second. So what we've seen is we've had people swing loads over to the load control circuit itself and not commission a system or partially commission a system. And they turn it off, wait for PTO, and then they get a call from the homeowner basically saying that my loads that are on that load control breaker aren't working. And the reason for that is from the factory, the combiner the combiner 6 ships with that load control breaker relay in the open position, right? And only once we commission that system and tell it that there's something there, that's when that relay will actually close. So those loads are usable at that point. So in the installer toolkit or the installer app, we've changed a couple of things. So when we go through the configuration process for it, we have to tell it the size of the breaker that is in that specific slot. That's that middle graphic that we have that arrow to. So we select load control, then you select the breaker size. And then in the next screen, you're going to say load control, and then you can actually tell it how you want it to connect. Do you want to have a basic, schedule, advanced, things like that. But the big takeaway is we have to make sure that we configure that load controller out of the gate to make sure that if you do have any loads that are on there, they're going to be usable when you leave that job site for that homeowner. And so again, just want to make sure that you guys are fully aware. Even if the system doesn't have PTO, you still need to commission to at least that point to make sure that that relay is closed so those loads will work.
Yep. Yeah, we pretty much with the 484 software, like Jarrett said, we put a secondary line of defense. If you didn't configure it before, like in 483, the previous generation, it would just stay open. Customer wouldn't get access to those loads. And 484 pretty much is once you define that load control breaker like you see here and you put what it is, it's going to recognize like, hey, we got to actually configure that. And then like Jarrett's saying, you're going to go through here and actually, you know, pick out all the settings and stuff that you want for it. So cool. Let's talk a little bit about battery power state. So this is specifically around when you don't have PTO or you don't plan on commissioning after installation. So these are some things that we really want to, you know, focus on and make sure we understand. And this all revolves around not draining the battery to an irrecoverable state. So first thing here is we do not want to leave the battery DC switches on without completing functional validation. So if you install everything, you know, put the DC switches on and have everything on, but you don't actually plan on getting into your installer toolkit and actually going through all of the validations and functional validations that are needed to complete the system, we do not want to put those DC switches on. We also do not want to leave the DC switches on if the battery AC breakers in the combiner are off, okay? We also don't want to do that. And then we also do not want to plug in the DC connectors. So this is we were talking earlier. You can see the bottom picture here is we do not want to actually put the DC connectors into the micros unless we plan to fully commission, okay? Now, if we do want to commission, but we know that the system's not going to have PTO, okay? So you can go ahead and plug everything in, commission, and then what we want to is actually we want to unplug these before we leave the site, so there's no possible way to drain those batteries if we have extended PTO delay. So say it's like 3 weeks, 4 weeks. I've even heard it over that. We just don't want to, you know, put the state where it's drawing, you know, a little bit of current and then eventually taking it down to an irrecoverable state. So again, just think of these. Think about if you're commissioning, if you're not, and then if you have PTO, and just kind of follow this guidelines and these rules here. What do we got next here? Are we at Q&A? Let's see here. Oh, looks like my screen.
We are.
Perfect. There we go. Yeah, we got 3 minutes, folks. We're not going to hold just to 3 minutes. We're going to give everybody a little time. Let's open it up for some questions. Peter, Jeremy, I see Danny's on. Do we want to run through some questions that were asked, and what do we have out there?
Hey, John, this is Tony. I'll jump in here since I answered several questions that were posted.
Hey, Tony, thanks for jumping in.
Yeah, no problem. There were a few questions about approval of the meter caller in different jurisdictions. So as was probably mentioned earlier, we're actively pursuing meter caller approval behind the utility meter in as many utilities as possible across the country. We have field application engineers that are tasked to kind of chase down whichever people they need to in order to get that process going. There are certainly bigger utilities that have been prioritized that have just more customers where there's kind of a greater need in the industry, and some smaller utilities may not be getting as much attention at this time. But we have a list on our website where you can see kind of which utilities have been approved and where we're pursuing it. And if your utilities are not listed there, I can put a link to that page in the chat as well. If it's not listed there, I recommend reaching out to the Enphase RSM or field application engineer in your region, and they can give you more kind of specific information on approval of the utilities, especially smaller utilities in your region.
Oh, yeah.
Yeah, can I add one more thing to that since it's expanded? Yeah, hey everybody. So I did also reply to a question about this, and I think I sent the response back to everybody with the link to the Enphase site, which provides information of where you can look up the status of the approvals. And then I did put a little note that if you are working with municipal power utilities that we don't know about, but you want us to know about, and you have contacts, please email those contacts to us so that we can contact them and work with them to approve the meter collar. You can imagine how many hundreds of utilities there are, or thousands. So we can't reach out to all of them, but if you've got some contacts, that helps facilitate this. And so please send that to us. Okay, back to you, John.
Yeah. Thank you, Peter, for the added details, and yeah, Tony, thanks for explaining that as well. Good stuff.
I got one for you. This was actually one of my favorite questions because it's all about this. So someone asked, how do we train our own teams? So there's a couple ways to do that. So it's like the question was really corresponding to how do we download this so we can train our own teams? Well, one is this webinar is every Thursday. So, hey, I happen to know, former installer here, every single installer I've ever met puts earbuds in their ear when they're installing. No, not all of them, but a lot of them put earbuds in their ear when installing and can totally listen to this webinar every Thursday in the background. They're probably already listening to something else, just have them listen to this webinar every Thursday. We'd appreciate it. Number two, the best practices document was and is in the download section of this actual training. And then thirdly, maybe we should go back to the slide that shows all the resources, John, when you have a second. But we have a ton of resources, be it YouTube. We have the best practices document for 4th generation. The bottom line is there's a ton of just information for you all to be able to actually train your own teams, which we do appreciate. Some of us are actually former trainers at installation companies. So we're happy to have you do that as well. But hey, just invite them. This webinar is also recorded and will be sent to you as a recording. So let's say you've got a team of people that you want to get all this information to, and okay, fine, they can't join at this time at their day, no problem. Take the recording and say, please watch this. You can forward it to them. You can forward the recording, but invite them to the next call, have them register. So anybody that registers will get the recording. So yeah, and then take a picture of the screen right now, and you can get the best practices document, if you want as well. Quite frankly, I got to be honest, a lot, and I'm straight up honest guy. The majority of the time I get customer service calls or look at the customer services queue, it's generally an installer that is using a shared login, and they're not the certified one. So I'm going to be honest with all of you that if you don't have certified crew members, they're the ones that are going to be slowing down and losing profit on the job because they don't know how to install the product properly. So please make sure that everybody physically installing the project is certified. It's your name on it. It's your project, but you need to make sure you're certified. think about it this way. You're a professional. You're acting as an electrician, whether you are one or not, you're acting as one. And if there's heaven forbid, a fire or a wiring error at the home, that's on you. So the best thing you can do is make sure everybody that actually touches the product is certified in the product. And then quite frankly, everybody that is touching that product in general or influences that project understands that project. So designers, for example, if they're sending you plan sets that are bogus, talk to the team and be like, hey, it's time for you to go get certified by Enphase in the design on the 4th generation. So I know that was a long rant, but it's my favorite question that came in today.
No, that's awesome, Jeremy. Thanks for elaborating. And I 100% agree with you. And yeah, good stuff, man. I really appreciate that.
All right. Hey, John and Jarrett, there's a question. What if we have the meter collar approved from the utility and the system fully commissioned, but not have full PTO yet? Can we leave the DC connectors plugged in to save on the return trip to the site?
Yeah, so we've been directed just so we don't have any depletion of the battery. So we've been directed as of right now to actually turn off the batteries and actually disconnect those DC connectors, just because we've seen extended PTO times and things like that, and having those batteries get into an irrecoverable state is unfortunately what we've seen. I know Sunil, I know you're on. I don't know if you want to add anything else to that, Jeremy.
Let me add something there too. Yeah, just because you disconnect the DC connector to the battery, like to the switch, just because you disconnect it doesn't mean the inverters are off, right? So you actually have to shut down the battery. So there's two things. One is AC breaker on to the batteries. Okay, we trickle charge the battery a little bit if you see a state of charge below a certain percentage, fine. But most of you are leaving the site, turning all the breakers off. You gotta turn DC off. So otherwise, you're going to drain the battery cell pack. You've gotta disconnect the micros or else you're going to drain the battery cell pack. So what happens when you drain the battery cell pack? Irrecoverable battery. So the bottom line is, the way we're instructing you all is that if you don't have PTO or you're not leaving the system in the operational state, especially if you aren't commissioning, disconnect the DC, disconnect the micros from the batteries, those microinverter plugs from the batteries, and disconnect the switch, but make sure the switch is in the off position. So that's the bottom line. Yes, we understand it's a return trip, but it's better to have a return trip to plug everything on and turn it on than it is to have a return trip with a dead battery.
Yep. Good question. Thanks for the details there, Jeremy. And then yeah, thanks, Peter, for bringing that one up. That's an important one.
Sure, got another one coming your way, and I think there's two questions that are sort of related. So I'll ask the first one, and then we can kind of relate it to the second one. The question comes from Dennis. For clarity and understanding, what does the AC Sense connection do? And how and what does it interface with? With a remote combiner 6C and an IH requiring a rapid disconnect switch of 100 amps, why can't the AC Sense switch be used instead of an unsightly 100 amp disconnect switch? So I'll pause there because there's a little more to this, but I'll let you answer that first.
Yeah, great question, and fair question, honestly. So the AC Sense is a 120 AC loop, okay? And so what we currently do is we intercept the back feed with like you said, like 100 amp disco, a 3-pole. That's going to be your line 1, line 2, and then we're going to use a smaller wire to actually disrupt that AC Sense. And what that does is that signals to the combiner to open relays, to open put the batteries into an idle state, signals to the roof. We are working too, Dennis, on being able to just use the AC Sense. The reason we don't now and we don't promote it is because we don't have it UL listed. We didn't certify it that way, but we are looking at getting like a toggle or like a push button, where we can actually utilize that AC sense and not have to use that big 100 ampere, which obviously doesn't look great, obviously costs some money. But we are working on that. But as of right now, it does require a 3-pole, and we do need to disconnect it, using that AC sense. So more to come on that. I don't have an ETA when that certification is going to be, final, but we are working on it, Dennis, and we are aware of what you're saying.
Yeah, so John, and everybody, so there was a kind of a parallel question. This is related to a specific utility that this person mentions that says that this utility still wants us to use an external e-stop switch. And is there a tech brief describing how to piggyback that on the PV aggregate for the external e-stop? And so kind of the similar question, we do have this in the quick installation guide, a diagram of how you extend your rapid shutdown mechanism out and use the AC sense for actually stopping production as well. Now, what John mentioned is that we're trying to certify just using this function of AC sense to turn off everything, essentially from a single low voltage button. And so, John, I've got the latest I've heard is somewhere between December and January, we should have a qualified and certification for essentially being able to do that through the AC sense alone without having to extend the PV aggregate 100 amp circuit out. So just to embellish that a little bit. Yep.
Thanks for that timeline, Peter. That's good to know. I knew it was coming soon. I just didn't know kind of when yet. So awesome. Great question. What else we have there, folks?
There were a couple of questions about design that I could address here as well, for the benefit of the group. So one of them was essentially about main panel upgrade avoidance using Enphase power control, specifically the type of avoidance or the feature called busbar overload control. So, this is a new feature. This is kind of a new concept to some folks who haven't used it before. So the question was basically, if I'm using PCS, do I still have to derate the main breaker in order to have enough capacity to add a large breaker for the backfeed? And the answer is, the whole point of busbar overload control is that you can not have to comply with the 120% rule because you're using a different bit of National Electrical Code that applies to PCS. So with a 200 amp, the example they gave was a 225 amp panel. That's the bus rating with a 200 amp main breaker. With that type of panel, you can actually connect or install a 125 amp breaker for the backfeed breaker, and you would set in PCS, you would designate that's the backfeed breaker, and the system would actually be able to backfeed 100 amps of continuous current to the main panel without any derating required. And let's see, there was another question regarding how to do whole home backup or partial home backup if the utility hasn't yet approved the meter caller. You guys may have talked about this earlier in the session, but basically that's when we look at using a standalone meter pan or meter socket, they're sometimes called. Essentially, that meter collar is not going to be put behind the meter itself because it's not approved for that, but you can still install it on top of a separate meter pan, which would be located electrically between the backup loads panel and the main panel for a partial home configuration, or between the meter and the main panel if you're doing whole home. And you install that meter collar on the meter pan with that jumper cover on top, and that acts as the MID or microgrid interconnect device to disconnect from the utility grid for backup situations. So yeah, hopefully that clarifies those two items.
great description on the PCS, Tony, and then yeah, great description on the non-approval. That's spot on. Great stuff.
Okay, another question we had is some AHJs we work with require a separate wall-mounted RSD or rapid shutdown device to be installed. Does the battery come with its own RSD like previous generations, or would we need to purchase that separately?
Yeah, so two things on that. So we actually have our battery, the actual switch themselves that we talked about for the 5-second press on, 5-second press off. They actually have a cover that actually has a lockout tagout capability. So if the HA allows that, you can simply utilize that. Or if you must have a disconnect between the battery and the combiner, you're just going to use the appropriate rated disco. We do not provide that, but you will have to install one between the battery and the actual combiner. So again, we do have it certified for that feature of lockout tagout with those doors, and it has a little lockout capability. So again, it depending on if your AHJ allows that or not, or if they actually want a visible knife disconnect.
Yeah, it is a qualified means of disconnect.
Yep.
But as John mentioned, if they're looking for a blade disconnect, then they'll have to put that in. But from a disconnect perspective, the buttons on the battery, if it's readily accessible, then it is a qualified means of disconnect.
Yep. Yeah, we got quite a few areas that do allow that, but I get it. Blade disconnects are what we're used to seeing, and some areas are just going to want those. What do we got? We're about 15 minutes past, folks. So I appreciate hanging in. Why don't we do one or two more, folks? What do we got, Peter, Tony? We got any more?
So we had kind of had a follow up. Oh, sorry.
No, please go ahead, Peter.
Yeah. So we had a follow up in regard to the AC sense wire, because we mentioned that it's coming, and it will be actually a qualified means of having a single button e-stop. The question was, will the modification of the AC sense in the combiner 6C be retro updated in existing combiner 6 without buying a new 6C?
Yeah, I believe that's just going to be obviously updated in our certification, and then I believe it's just going to be software related. Peter, or I think Sunil, looks like Sunil had a drop, but I believe it's going to be those two things. I think it's going to just be a new certification for means of disconnect, and then I think it's just going to be software related. So I think you're going to be able to use your existing combiners that have already been installed or already purchased, and then obviously going forward, it's going to be have the capability.
Yep, that's right. So the functionality will not require any kind of hardware change. So the existing combiner 6C will be qualified. The AC sense wire mechanism will be fully qualified, and we'll be able to tell everybody about this in broad terms. We can't do that right now because it's not technically certified, right?
Yep.
Okay.
Yep. Awesome.
Good. Oh, Tony, go ahead.
Oh, yeah, that's right. Tony did have one. I'm sorry. Go ahead, Tony.
Oh, this is an easy one. This just has to do with where you're allowed to run the Enphase control cable. Can it be run with the DC conductors? If you're retrofitting or you're doing an expansion system with Enphase on a string inverter system, there might be instances where you've got DC conductors in the raceway. The answer is simple, yes. Like, this is a high quality shielded cable that is the control cable from Enphase, and you can run that cable alongside either DC or AC power conductors. So that's what I had.
Oh,
Awesome.
I had such a good joke. I won't even say it, but about DC conductors, but it's all good. Hey, I just wanted to make one little note, because someone called it out and really just asked, like, hey, the disconnecting means, or keeping the micros and the DC switch to the off position, that wasn't in the certification. They're straight up right. So we built and Peter Lum's on the line, the professor, as we call him, is on the line, built that certification for y'all. Tony Vernetti had a lot to do with it as well, and they're on the line as well. We built that back in, gosh, what, Peter, May or April? I mean,
Yeah,
it was,
way back.
yeah, yeah, I was a younger man then. So we built the certification, and a lot of you were certified since then. So one of the challenges of being a training organization, and Peter's probably the longest tenured trainer on this call, one of the challenges of building a certification and then releasing a product to the wild is those of you that take the certification probably won't ever come back because you're certified. But how do we get information to you that are actually doing in the installs after the certification? And that's the call today. So that's why it was so important to us. And straight up, Badri, our CEO, said, hey, look, guys, I think you need to do a weekly webinar for our installers so that they can get the most information after they take their certification. And that's why we're here today. So that's why it was so important for all of us to do this and make sure we spent time with you. And quite frankly, Peter, your certification led us into the next level. And I just, on behalf of all of us on the line right now, as trainers and as installers in the field, I just want to say thank you, Peter, because we really appreciated all your work with this.
Oh, thanks, Jeremy.
Alrighty, guys. Unless we have another question that's burning a hole in our pockets, should we call it, or do we got anything else?
I think we've answered all the questions that came in pretty well, and they're always, sometimes a couple of stragglers that come in that we can address by email at a later time. But I think we're good.
Awesome. Well, I want to say thank you to my co-host Jarrett. Thanks for being here and presenting. Really appreciate it.
Always a good time.
Peter, Tony, Jeremy, thank you for answering all the questions on the back end and getting those typed out, and a little Q&A session here at the end. I appreciate everyone and all the support. And folks, we'll see you again next week, same time. Remember, week of Thanksgiving, the week after, we're not going to be here, but we'll be here next week. So please join, and we'll see what we have new next week. So thanks for joining. Thanks for all the questions, and we'll see everyone again. Take care, folks.
Thanks, everybody.
See y'all.